Hello, scientists! Today we'll be reviewing matter and talking about what happens when the cell has different concentrations of substances on the inside and on the outside. First, we'll start with a review of matter. We divide matter into two categories, pure substances and mixtures. Pure substances each have unique properties, while mixtures take on the properties of their different components. We divide pure substances into elements and compounds, and we talk about both homogeneous and heterogeneous mixtures. Let's look at each of these in a bit more detail. Elements are the building blocks of matter. We find them on the periodic table. We also sometimes think about them as the identities of atoms. Examples of elements include hydrogen, oxygen, sodium, and chlorine. Compounds are two or more elements that are chemically bound together. There's some kind of a chemical change that has created a link between elements. These are things like water, which is two hydrogens and an oxygen chemically bound together, and salt, which is a sodium and a chlorine chemically bound together. Compounds each have unique properties that are different from their component elements. So for example, sodium is a white metal solid, and it's explosive when we put it in water. And chlorine is a gas that is poisonous. But when we take these two things and chemically combine them together, we get table salt, which we eat every day and is necessary for life. And so we lose the individual properties of the elements and gain new properties of the compound. Mixtures are divided based on how they look to our eyes. So homogeneous, the prefix there is homo, which means the same. And a homogeneous mixture looks the same. All of the pieces look the same to our eyes, so we can't see the different parts. Scientists also call homogeneous mixtures solutions. Examples of homogeneous mixtures include lemonade, coffee and sugar, or tomato soup. So in lemonade, we have three components, lemon juice, sugar, and water, but we can't see those individual components. However, lemonade is composed of the properties of these different components. It's watery, it's sweet, it tastes like lemon. Heterogeneous mixtures are ones in which we can see the individual components. The prefix hetero means different, so we can see the different parts. Examples of heterogeneous mixtures include chicken noodle soup, salad, and trail mix. In chicken noodle soup, we can see the chicken, the carrots, the noodles, the broth, and they're physically mixed together. And we can also detect those different components with our senses, right? We can taste and smell the different components individually. I'd like to look at solutions in a bit more detail. Again, a solution is the scientist's name for a homogeneous mixture. And we use some different vocabulary for the parts of a solution. So first we have a solute, the substance that's dissolved in the solution. So in my image here, it's the dots. If we're thinking about salt water, it would be the salt that's dissolved into the water. And then we have the solvent, and this is the substance that does the dissolving. So it helps spread out all the individual solute molecules so that they can't be seen with our eyes. So in salt water, water would be our solvent. Often the solvent is found in a greater percentage, but not always. So you have to be a little careful with that. And then I have my example here. So in salt water, salt is the solute and water is the solvent. And finally, we use the word concentration. So this is a measure of how much solute is dissolved into the solvent. As you go through your career as a chemist, you'll learn some different units for concentration, but for now we're just going to use percent. So we might talk about the percent of salt in a solution. If it's a 10% salt solution, then the remaining percentage would be water. All right, now we're going to talk about the process of how different components of the solution move across the cell membrane. So first we're going to talk about diffusion, which is the movement of particles from an area of higher concentration to an area of lower concentration. And diffusion is something that we experience often and just in our regular lives. So if you were to light a scented candle or you were going to spray a room freshener, you would notice that the scent particles or molecules start close to the spray or to the lit candle, and then slowly they'll diffuse or spread throughout the room So they start at the area of high concentration, the source, and they'll spread to areas of lower concentration, the far reaches of the room. We use the word osmosis to talk specifically about the diffusion of water. So when we think about our cell membrane, we know that we have some proteins that provide channels, but often the thing that we think about flowing freely across the cell membrane is water, and then we think about other molecules as sort of being stuck on either side unless they're specifically transported. So we're going to talk about a few different situations. We can talk about cells as being hypotonic, which is the situation where there's more solute on the inside. In this case, let's think about salt. Now, we want the concentrations to be even, or the natural thing that happens is that the concentrations will even out. The salt, however, the solute, can't move across the membrane. So the material that moves is the solvent, or water. So here, if there's more salt on the inside, that means there's more water on the outside. And the water will move into the cell across the membrane. So the water moves from the area of where it is high concentration to where it is low concentration. And the result is that the salt concentrations will even out. In a hypotonic cell, as water moves in, the cell will actually spread or become larger, physically larger. And so one way that people think about remembering this word is that hypo sounds a little bit like hippo, and hippos are large, and so the cell becomes larger. The opposite of a hypotonic cell is a hypertonic cell. And in this case, we have more salt or solute on the outside, which means that we have a higher percentage of water on the inside. So again, the salt can't move across the membrane, so the water is what's going to move. And the water will move out of the cell in order to even out those concentrations. As the water moves out, the result is that the cell will shrink. So a hypertonic cell, water moves out of it and it will shrink. The final scenario is an isotonic cell. And in this case, we have the same amount of same concentration of solute on both the inside and the outside of the cell. So while water will move across the membrane, there won't be any net movement. It will come into and go out of the cell at an equal rate. And so there will be no change to the size of the cell. In an isotonic cell, there are equal concentrations of solute and the cell size does not change. So in summary, water will move from areas of low solute to high solute until the concentrations of solute are the same. And this can change the size and shape of the cell. That's it for today. If you have any questions, please leave them in the comments below.